algebra students, Mr. Lawrence here with your first flipped lesson. This lesson is on integers, adding, subtracting, multiplying, dividing. It should be something you've already mastered. We're going over it to make sure you do know how to do it. Now, look, knowing how to do it is important. Knowing why it works is even more important. And I got to warn some of you. Some of you think you're in the same old math class that you were in last year. I got rude awakening for you. This algebra class is a high school level class. It will be the most challenging class you've ever taken in any subject up to this point. Hopefully it won't be the most challenging class you ever take. It is going to require you to think, to push yourself, to do more than just get your homework done. You're going to be required on tests to explain why things work, not just be able to do them. Okay? You're going to think. You're intelligent enough to be in this class. We've got to make sure you have the right work ethic. Now, I will be offering some help after school. I'd love for you to come in and get help. But you need to be giving your best effort all the time, or you are going to get grades lower than you're used to getting. Okay? Now, the payoff will be if you work hard, regardless of what grade you get, you will learn more than you've ever learned in a math class before. I promise you that, at least until next year. All right. Let's talk about adding and subtracting integers. A real good way to do this is to work on a number line. This is one really good way to do it. And I'm going to get this little counter out here, my little counter friend. And I'm going to do this black problem here, 2 plus 3. I know you all know the answer is 5, but let's see how we could model this using the counter and the number line. I'm going to take this counter and I'm going to put them on the 2 on the number line. Then I'm going to look at this plus 3 here, and I'm going to move that counter. Oops, there was a little mistake there. I'm going to move that counter 3 in the positive direction. Okay, so because of that plus 3, I'm going to move 3 in the positive direction, which would be to go 1, 2, and 3. And there you go. I've just modeled the little counter guy will end up at the spot 5, and therefore 2 plus 3 is 5. Now, I know you all knew that 2 plus 3 is 5, but we just proved why. I'm going to demonstrate that another way in a minute, but let me go through these other examples here. Okay, so let's take my little counter guy this time. I've got to do 2 minus 3. Let me get rid of that. And let me go to 2. Starting at 2. Now I need to go 3 in the negative direction. So I'm going to go 1, 2, 3. Okay. Well, the counter moves to the spot of -1. And therefore 2 minus 3 must equal -1. Now, in your tests and stuff, I may require you to model it like this. But in general, I want you to be able to know the answer. This is stuff you should have already mastered before you've gotten into my class. I know it's not true that all of you have mastered it, so I'm showing you how to model, and I will require you on tests and quizzes to model it. But you need to commit this to memory and be able to have a very good working definition of it. All right, this one here, I need to go -2. So I put my counter on -2, and then I need to move 3 in the negative direction. Well, that would be that way again. And so I'll go 1, 2, 3, and I end up at -5. So therefore, -2 times -3 is -5. All right. Now, one other way I wanted to model this is using some counters. I've got some positives and negatives down here. All right. I've got 2 positives for this black one, right? There's my 2 positives. Move them over there. And now I need 3 negatives. Oh, excuse me, no, 3 more positives, right? Because I'm doing the black problem. Boom, boom. There's my 3 positives. Nothing cancels out because positives don't cancel each other out. I have 5 positives altogether. And therefore, I have +5 for my answer. For the blue one, I need 2 positives. But then I also need 3 negatives. So I've got 1, 2, 3 negatives. Now, what do positives and negatives do? Well, they cancel each other out. So these two here they're gone. Boom and boom. They cancel each other out. These two cancel each other out, leaving only one negative, or -1. And there you go. Now to do the red problem, I need 2 negatives. And then I need 3 more negatives. Nothing's going to cancel out because negatives don't cancel each other out. What do I have altogether? I have 5 negatives. -5. You might notice that when the signs are the same, like in 2 plus 3 or -2 minus 3, that you do them the same exact way. You're basically just counting or adding. When the signs are different, you end up subtracting. Okay, now if you need more practice with that, there's going to be another video attached to this one. Practice just for adding and subtracting of integers. It won't be long, but it'll have lots of practice for you. If you totally have this mastered, you don't need to watch that other video. Let's move on to multiplication and division. All right, now you see I have a number line here, and I have some little people. These little people are toddlers learning to walk. We'll call them Bobby. All right, he's in different colors so that you know which Bobby goes with which problem. Now, first of all, we're going to take 2 times 3. Now, big problem, reason students have trouble with this is they don't understand that when you're talking multiplication and division, you're talking about grouping. This means 2 groups of 3. 3 what? Well, it's actually going to be moved 2 groups of 3 moves. I'm going to put my black Bobby here at 0 on the number line, and I'm going to have him do 2 groups of 3 moves. And because the 3 is positive, he's going to go forward. And you can see he's wearing a little cap here, so it's safe to assume he's facing the way the bill of his cap is pointing. I could put a little arrow on that if I wanted to. All right, so Bobby is going to move 3 spaces and then 3 more spaces. So let's have him move 3 spaces. So 1, 2, 3, and 1, 2, 3, and look at that. Bobby ends up on the space for 6. 2 times 3 is 6, which you all knew. Okay, now on the blue one, again, he starts at 0. Bobby's going to do 2 moves, right? 2 groups of moves, but he's going to go -3, which means he's going to walk backwards. Yeah, Bobby's walking backwards. How come? Because it's -3. So he's going to go 1, 2, 3, 1, 2, 3, and there you go. Bobby is at -6. So 2 times -3 equals -6. Now, on this one, Bobby's facing the other direction. Why do you suppose Bobby's facing the other direction? Well, if you don't know, I will show you. It's because the 2 is negative. I need the groups. I need negative groups. I need them to go the other way. Now, the 3 is positive, so Bobby is going to move forward. He's turned around, so he's going to move to the left instead of moving to the right. So we're going to go with 1, 2, 3, and 1, 2, 3. And look at that. Even though he's facing the opposite direction, he's still in the same exact place, -6. So 2 times -3 equals -6, and -2 times 3 equals -6. All right. This one, the red one, Bobby's facing left because the 2 is negative, and the -3 means he's going to walk backwards. So Bobby is going to do 2 moves of 3 backwards. 1, 2, 3, 1, 2, 3. And there you go. -2 times -3 is +6. Now, many of your parents would have learned, something like, well, you have a positive times a positive, that's going to equal positive. Positive times a negative is going to equal a negative. A negative times a positive is going to equal a negative, and a negative times a negative equals a positive. That's what I just modeled with those, with Bobby walking on the number line. Okay, these are good rules to remember. The problem is kids get them confused. They don't understand them. They don't know why. If you're not a kid that gets confused with it, you can do it that way. Wonderful. Hats off to you. No pun intended. But if you're a kid that doesn't get it, think about it with Bobby walking on the number line. Okay. All right. I'm going to sign off now. And remember, there will be 2 other videos for you that are not mandatory, but if you need practice, that's what they're there for.